Hello and welcome to today's video. We're going to be learning about how to translate equations. Now, hopefully we were able to, in class, do a little bit of review of writing compounds out and so forth as a review. If we didn't, then I've probably given you something else to do as a review for that. But we're going to get started. So we are going to be in your workbook on page 21. You need your periodic table and your yellow sheet out. You're actually going to need that out every class period for the rest of the 9 weeks. So have that periodic table and yellow sheet out so that you can refer back to that. So I'm going to go through this information here for you slowly, and you can get your notes, and then we're going to jump into actually doing the translation. So this first part is just a review, so I'll go ahead and pop that up for you, and you can pause if you want to and take the notes there, but this is just a refresher as to what are different symbols and what they mean. So when we see the G, remember it just tells us it's a gas. L's telling us that that compound is a liquid. S means that it is a solid. Cr means it's crystalline, like crystals, like salt crystals. And AQ means again that it is aqueous. And remember, aqueous means that it is mixed with water or dissolved in water. Okay. Also remember that our arrow, when we talk about that, means yield or produces. And so I kind of put this out there, but it could be that A reacts with B. So when we're talking about reacting, A reacts with B to yield something. So get those down, and then let's go on. The next thing I want to remind you is your diatomics. You're going to see these a lot coming up. Just remember that any of these, you have to have those memorized, those 7. They all are found in nature in pairs. They're never found alone. So they all have to have the subscript 2 there when they are by themselves in a reaction. And the last thing that I want you to note here is acids, because we are going to refer to some acids. We'll come back and talk about those. We'll also have you memorize some of them, but I'm just going to give you some here. And one of the things, how you recognize an acid, is that it starts with an H, okay? And so typically if we have a hydrogen that just has a 1 on the hydrogen, we call it hydrochloric. So we're going to take the hydro from the hydrogen and from chlorine, and we call it ic. So we put an ic on the end of it. That's another way you can tell that it's an acid. Okay, ic. Okay, so this would be hydrobromic. Okay, if it has generally a 2 or a 3, not all the time, but generally if it has a 2 or a 3 out in front, then we call it by the polyatomic that is with it. So in this case, this would be sulfuric acid. So polyatomic, we're going to call it phosphoric acid. Now, one that does not have a number, but is also one of those because it does have the polyatomic. So in this case, and this would be nitric acid. Nitric, sorry, that should be 2 words. So again, when they have the polyatomic, okay, then this is, again, sulfate, and so we call it sulfuric. Phosphate, so we call it phosphoric. Nitric, so we call it, or nitrate, so we call it nitric. Okay, so kind of remember that rule. Again, if it's just an element, we go with the hydro. If it is a polyatomic, we go with this, with the polyatomic out in front. Okay, and we'll talk more about those, but just so when you hit a couple of those today, you'll know. Okay, so we're going to go on to page 22 and look at some actual translations. Okay, so hopefully you're with me, and we are on page 22, and you have your periodic table and your yellow sheet out with you. And so we are going to be taking these equations and we're just going to be changing them to words. Okay, so one of the things that you need to remember is, again, your state of matter notation that is at the bottom, whether it is a gas or a liquid or aqueous or what it is. So when you look at this, you see that you have hydrogen gas, that it's going to react with oxygen gas to produce or to yield water. And you could say liquid water if you want to. Although with water, a lot of times we leave off the liquid piece of it because we know that if it was solid, we'd call it ice. Okay, so again, that's all you're going to write down for me is hydrogen gas reacts with oxygen gas to form liquid water. Okay, so don't make it difficult. Okay, oops. And if you need to pause so you can write, if I go too fast, just pause it. Okay, so this one, again, we're going to look at our states of matter. We have solid magnesium, we have aqueous silver nitrate, we have solid silver and aqueous magnesium nitrate. So we're going to say solid magnesium reacts with aqueous silver nitrate to yield solid silver and aqueous magnesium nitrate. Okay, so if you struggled back before Christmas break with the naming of these, you might want to have to go back in and do some review. If that's the case, let me know and I'll send you some review stuff. Okay, so again, here's how we write it. Solid magnesium reacts with, I forgot my aqueous when I wrote it out the first time, aqueous silver nitrate, if you forget it, just squeeze it in, to form solid silver and aqueous magnesium nitrate. Now, just a reminder, guys, if you are working with your transition metals, remember you're going to need the Roman numerals in here. Remember, if you're working with covalent bonds, you need your prefixes, like carbon dioxide, you're going to need a prefixes. Now, for the most part, the ones we're doing today are not covalent, they're just ionic bonds, metal and non-metals, and you won't need prefixes. Okay, but you might need some Roman numerals. Okay, we are going to skip 3 just for now, just because we do need to come back in and talk just a little bit about how to name this one here. Okay, so skip 3. Okay, number 4. Why don't you try that one on your own, see if you can get it. Again, use your states of matter. Be sure you put them out in front, so those go out in front of the word. And you're going to need your yellow sheet to look up these if you don't know what they are already. So pause and then see if you get it, and then you check it with me. Okay, it should be aqueous aluminum sulfate reacts with aqueous barium chloride to form solid barium sulfate and aqueous, I ran out of room, aluminum chloride. I wrote that too big, so let me slide that over. Okay. Okay, so how are you feeling about this now? So we'll go ahead and go to the next one. Now, this here, when you have one reactant here, so I don't have 2 things, there's no plus sign here, and it forms 2, this is actually a decomposition reaction. And we'll learn about all the different types. Okay, decomposition. So we say this decomposes to these 2. So take a minute and see if you can figure it out. So this decomposes to form these 2. Okay, and the answer is solid sodium chlorate decomposes to form solid sodium chloride and oxygen gas. Okay. Try the next one. You might need to go back to your notes because I told you what this one is. Okay, so it should be aqueous hydrobromic acid, that's what this is, reacts with aqueous potassium hydroxide, and I'm bad about forgetting that myself on there. Let me scoot this so you can see. Get me out of the way. Okay, to form aqueous potassium bromide and water. Try to see if I could widen that screen just a little bit for you, but don't want to mess it up. Okay, aqueous hydrobromic acid reacts with aqueous potassium hydroxide to form. Okay, so we're going to stop here, and then the next thing that we're going to do is practice some of these.